In the name of Allah, the most gracious, the most merciful. I am Engineer Hani Kamil. In this video, I will talk about tab changer faults, like if transition resistor already have short or cut, or fault between tabs, what the protection will operate and protect transformer. So let us see. Before we study faults inside the tab changer, we need to understand the operation of tab changer, and here already I brought example for vacuum tab changer, which already used vacuum capsule or vacuum switch during current interruption. So for example now, our tab changer already in selector switch in tab number 1, and we need to move tab number 2. The current now is going through the tab number 1 through the main contact. So first will transition contact or resistor contact will start leaving tab number 1. Then the vacuum capsule or vacuum switch will open before reaching tab number 2. Now the resistor auxiliary contact will reach tab number 2, and still the vacuum switch already open, so there is no arcing will happen inside the oil. And now vacuum switch will close, so the arc only will happen inside the vacuum capsule or vacuum switch and will be interrupted by this vacuum switch. And in this case, in this time, there is a short circuit between the regulating winding between tab 1 and tab number 2. And to limit this short circuit, already there is a transition resistor will be added. This only during this short circuit time, which almost around 10 milliseconds, or depend on the tab changer type. And this resistor will limit the short circuit current. Now, before the main contact leave tab number 1, the vacuum capsule of the main contact will open, and the arcing will happen inside the vacuum capsule only, not inside the tab changer oil. Then the main contact or main moving contact will leave tab number 1. Then it will reach tab number 2, and vacuum capsule or vacuum switch for main contact will close. Arcing, little arc will happen, and all this will happen inside the vacuum capsule, not inside the tab changer oil. And the main current now will go from tab number 2 through the main contact or main moving contact to load or to close the circuit to the main circuit. And now the resistor branch will not have any current flow. Next, we will start to study tab changer problem by MATLAB Simulink. Using this simulation, I will start with normal condition. We have transformer 67 MVA transformer 132 over 13.8 with plus 12.5% minus 20% regulation range, 27 tab, and DYN1. I will start our simulation. Now our transformer already at no load condition, and our bus voltage low voltage side 13.8 kV bus 90% because I already started at tab number 1 to minimize the inrush current. I will make the AVR in automatic mode, so it will regulate the low voltage bus. Now the voltage is inside the band, or inside the regulating band. I will start to add load. Now voltage drop again, and AVR will continue regulating the bus voltage. Again the bus voltage already regulated. I need to check the current waveform in high voltage side. We can see is our current sine wave and voltage sine wave. Just it's not smooth because the sampling time. And we can see these points during tab changing, and already current will never drop to 0. We can see the RMS value, and same current not drop to 0, and this peaks just because during the tab changing we said we already make short on 2 tabs. That's why it will be there is a short circuit current, but the resistor will limit this short circuit current. Now I will start to problem in tab changer, like I will open or I will make damage in one resistor. For example, it will be before it was 3 ohm or 6 ohm. I will make it 6 kilo ohm, means like bad contact or problem in resistor. Now I will start simulation again. Now AVR will start to regulate the bus. We can see what happened in current. The current already have some peaks, down, drop down, and go up again. Even problem now clear also on the voltage. Now the bus voltage regulated, but let's see the current waveform. You can see the current already have drops in R and blue phases. It will not reach 0 because will make some arcing inside, but you can see the current already dropping during tab changing. Also we can see the sine wave. For example here, already there is difference in current in this period. We can see the blue phase drop and R phase also drop. Now I will move to next case. I will make short in one resistor. And I will make run. Now tab number 1, AVR work in regulating the winding or the voltage on low voltage bus. Tab changing now. Load is around 60% and bus voltage regulated. I will increase the load, voltage down, and load now near 90% and tab changing to regulate the bus voltage. And transformer already get trip. You can see the disturbance recorder. This differential protection. You can see this is the current RMS. You can see the peaks during tab changing now is more due to the short circuit on the resistor, the switching resistor. And when we increased the loading and add some tabs, the current difference between high voltage side and low voltage side is more than the setting of differential relay. That's why it gives trip. I will go to differential relay curve or differential relay measurement. This phase A. It didn't give trip. Phase B. No trip. Phase C. It already gave trip. So the differential for phase C operate. One more time we will check the graph. and I'll make graph on. Now tab changing. You can see it is near to the limit, and blue phase already crossed the minimum differential current. That's why transformer give trip. So at some value of load, if there is any problem in transition resistor, current can increase the limit for differential relay and can give trip to protect transformer. We'll normalize again. Now I will start to make another fault in tab changer. I select one from the tab changer contact and I will make phase to ground fault. Now the tab changer working, or the AVR working to regulate the bus, voltage. I will make phase to ground fault, so the transformer give trip, or the protection give trip. You can see the disturbance recorder. We can see the differential protection because it's internal fault in the differential zone. Now I will move to face fault inside the tab changer. So I take one contact from R phase and one contact from yellow phase. I will remove this fault. Now run again. Now the AVR working to regulate the bus voltage, and I will make fault, again a trip. We'll see the disturbance recorder. Again is differential protection. I will make continue and I will make force reset. We can see the differential graph. It's already the red and yellow current in the trip zone, also blue phase also in the trip. That's why we have differential operated, because it's in differential zone. At the end, thank you for watching my video. I am Engineer Hani Kamil. This is my contact as shown. Any suggestion or discussion, you're welcome. you can contact me directly. Don't forget to subscribe my channel to get notification for coming video.